what I'm going to try and do is just give you a brief insight into the next industrial revolution. And if you were at the plenary session this morning, there was a very correct statement made that the next industrial revolution isn't necessarily the fourth one. In China, they regard it as the fifth one. So that's why we talk about the next one, but we do talk about the fourth one. So FIR, you'll see a lot in future all around South African publications. And we're even participating in Mexico in November, where we're going to actually try and explain how a developing country deals with the fourth industrial revolution. But one comment up front, and I'm going to show you a Siemens video clip, because this is partly sponsored by Siemens. But I do want to make a comment that product lifecycle management is an open platform. It's an open domain. So, and I think Siemens also tries to make that message very, very well heard, that many different software systems get integrated in product lifecycle management, to the extent that there are legacy systems around from Dassault, not only legacy but also highly advanced systems from Dassault and PTC. And these are used by manufacturers all over the world, especially in the aerospace industry. There is a strong presence of other software systems. So the point is integrating existing platforms into product lifecycle management. And that goes all the way through to implementation. If you talk about additive manufacturing, for example, we'll see a lot of manufacturers making additive or 3D printers, additive manufacturing machines, and these will be based on all sorts of software systems. So it's about integrating this into an overall lifecycle management. I want to start off by showing you this video clip. I'll just quickly get it going. And that'll explain a hell of a lot about what we're talking about.
What's one of the main drivers of change in the manufacturing industry? It's us, consumers. 63% of us want to have new products faster. 94% of us regularly search for alternatives. 61% of us are willing to pay more for higher quality. 74% have become more price sensitive. Another 60% of us want more sustainability. How can industrial companies meet these demands? By integrating and digitalizing the entire production, from the first idea of a product to its realization and even utilization. With the Digital Enterprise Suite, Siemens helps customers master their digital transformation. This comprehensive portfolio of software-based systems and automation technologies seamlessly integrates product and production life cycles and offers the ability to simulate, test, and optimize all processes. All this happens in a completely virtual environment by creating and using a digital twin. By utilizing data obtained from both products and production processes, companies gain valuable insights and thereby continuously improve the whole value chain. So things can be produced faster, at the highest of security standards and with utmost cost efficiency, with more individuality, while taking care of both quality and the environment. Siemens helps manufacturing companies to become true digital enterprises, and thereby makes individual dreams a reality.
Great. Thanks.
Siemens, ingenuity for life.
Start my PowerPoint. Thanks. So, after all of that, I don't think I need to present anything anymore. But I do think that there are some important messages which I'd just like to come back to, out of a developing country point of view, or from a South African point of view, also a country that is going to go through a lot of industrial development. And I'd like to just start off with this slide. And this slide really tells a story. And it's a story that technology doesn't solve all problems. And when we introduce technology, we actually haven't got any idea of all the use cases that are coming towards us. So any guesses what this is? It's a car, and it's got a white solid line drawn around it and a dotted line. And it's actually an autonomous vehicle trap. So if you've done your K9 recently, you'll know that if you drive over on a road, you can cross the dotted line, but you can't cross a solid line. Okay, so someone drew that into a parking place in Europe, and this autonomous vehicle drove in there and got stuck there and couldn't get out. So we don't know what the use cases are and what problems we're going to encounter on the path to introducing the next industrial revolution. And this is, in my view, going to create fantastic opportunities with the challenges that are going to come with it. And if one looks at how things are developing around us, the acceleration, the exponentiality, then if one just looks at the catalytic innovations that have occurred in the last century, and they were typically photography, automobiles, electricity, airplanes, and telephones, the list today is about 10 times longer. And it includes commercial drones, software development, mobile apps, 3D printing, cancer immunotherapy, LEDs, and I'll just jump right to the bottom, biofactories, microcolleges, smart homes and buildings, 24-hour cities, and senior living. We're all getting older. And a lot of the senior living is going to be driven by automation, and Japan is leading the way there. In the production process like this, one is creating a digital twin. That digital twin is a complete representation of your product. So imagine you've built a car. Every component of that car is stored, where it came from, what material was used, which manufacturer made it, when it was manufactured, what service requirements there are for that particular part. And if your car is now on the road and it drives into a service station, your service mechanic can pull up that data, that digital twin, and find out exactly what to do with this car. So that really democratizes the service organization as well, and that's a huge opportunity for South Africa as well, because you don't need to be a specialist in, let's say, a particular type of hydraulic pump. You need to have general knowledge about how to deal with hydraulic pumps, and when a particular hydraulic pump is presented to you, you're able, through the augmented reality, to get all the service information for that particular hydraulic pump presented to you. So hopefully that will also be a acceleration mechanism in training. So you don't need to train to the nth degree. You don't need retraining on particular things. The system will do that for you. Okay. The other thing is you get young people excited about technology. They can now service the parts. They want to understand how these parts were made, and hopefully it ignites the passion that they go back into training or into tertiary education, and then do study mechanical engineering, and then do become PhDs and design new products. So that's really, in a nutshell, what we talk about when we talk about Industry 4.0. I won't belabor PLM, it was mentioned enough, but Industry 4.0 will not be possible without product lifecycle management and the whole digitalization. And you're talking everything. You're talking starting with planning, styling, design of the product, simulation, the tooling of the factory, machining, assembly systems, robotics, the whole design of the plant, the quality management of the plant, production and supply chain management. So all of the components. You'll see brochures laid out here on the NISI initiative, National Industrialization Support Initiative. Thank you guys for starting that. I think this is really a fantastic setup where we are collaborating across government and industry and research organizations like CSIR, and we want to see as many as possible SMEs and even larger companies. Big products are fine as well. We have no problem dealing with big products going through this innovation system. I wanted to spend 1 minute on something that's very close to my heart, and when one talks about industry and innovation. And what we are driving is we're trying to get an exponential thinking going. And exponential thinking means that you have to harness 6 parallel processes. The first one is one needs to have education partnerships. So anyone who's developing and designing things needs to have a relationship with education institutions. The second one is research and development partnerships. That's where typically CSIR comes into play. The third one is innovation partnerships, and I differentiate on purpose between research and development and innovation. Innovation is making it happen, whereas research and development is blue sky. Then there's no good innovating anything if you don't have an entrepreneur in industry, someone who is going to live and die with what you have created. So it's your industry partnership. The industry doesn't live if it doesn't have an implementation partnership. And by implementation partnership, I mean funding. And there, IDC in South Africa is a very good example, but DTI also has some funding programs. And finally, the whole thing doesn't work if government isn't on board as well, which means your regulatory framework or your regulatory partnership.